Very good morning, everyone. My name is Aman Sharma from All India Oracle Users Group's North India chapter. And today we are hosting this month's webinar, which is going to be about the new features introduced in the histograms in the database version 12c. And the speaker for this webinar is going to be Ms. Anju Garg, which is going to be who is going to be presenting this webinar for you. And about Anju, she's an ACE associate. She is working as an independent database technologist, and she has been, presenting in multiple different conferences in India around, all the time. And she's also putting her thoughts about Oracle as well as her technical blog post on her blog, oracleinaction.com. So I will be just waiting for a minute or so for Anju to join us. I hope she's already in, but she's just going to take maybe a minute or two to join, and then we will be starting. If you've already connected, stay connected. I will be getting back to you in probably a minute or so. Good morning, Anju.
Good morning, Aman.
You're connected?
Yeah, I'm connected.
Okay, great. So Anju, could you please try to share your screen?
Sure. Well, are you able to see the slide?
Yes, definitely can. It has gone now again.
Can we start?
No, the screen is actually coming on and off, Anju. So,
Okay.
yeah, I think it is supposed to be coming up now. Can you make it full screen, please?
Yeah, sure. Is it okay now?
It's actually coming up as the view, just a normal slide view. It's not full screen. Can you make the display, the slideshow as a full screen one?
Yeah, it is full screen. Maybe it will take time.
Sorry?
I have changed it to full screen, but maybe it will take time to come.
Could be. Just a minute. Okay. I don't think so. It's still coming up as a full screen one, but can you try to move the slides, please, Anju?
Okay. Can you see the slide is, I have put it on agenda.
Not yet. It's not getting refreshed for me.
Okay, just a minute.
Maybe you can stop it and do it again. Yeah, now it has come for the agenda.
Okay. So maybe when I do it full screen, then it does not get updated, right? Now it is full screen. Is it getting updated?
Not really, Anju. It's still the slide. I mean, I think it's okay. I think you can keep it like this only if it is.
Okay, now are
Okay.
you the slide, right? Histograms Pre-12c.
Yeah. Just move it to one more slide, please. Like move it to from agenda, one more slide. Go to agenda, then move it to one more slide. Yeah, I can see agenda. Can you move it one more time? Yeah. Can you move it one more? Yeah, I need for histograms. Fine. I think we'll go with this. I think that's okay because rather than spending time on this thing, this is moving. So I think if you have any demo or something, maybe you can actually show later on. With the screen. You have any demos to show, Anju?
No, not really a demo. It would basically illustration, the screenshots on the slide itself.
Okay, fine, great. So I'll be giving it to you. So I think we are good to go. Once again, everyone, this is going to be the AI OUG North India chapters webinar from Ms. Anju Garg. And I've already mentioned to you that she's an ACE associate and she's working as an independent consultant now. You can check her blog, oracleinaction.com. And over to you, Anju, now. I'll be on the mute, right, and we'll be watching the presentation along with the others. Over to you.
Okay. Thank you, Aman, for your kind words. First of all, I would like to thank All India Oracle Users Group North India chapter who have given me this opportunity to present this webinar on histograms pre-12c and now. Well, Aman has already been very kind, but anyway, just something about myself. I am an Oracle ACE associate and I have more than 13 years of experience in IT industry. So currently I am a freelance corporate trainer for various Oracle core DBA technologies. Besides this, I have my own blog, Oracle in Action, and I also speak at various All India Oracle Users Group conferences. My email address is anjugarg66@gmail.com in case you want to get in touch with me. And I'm certified in various Oracle technologies. So let us start now. Well, what is this is going to be the agenda for today's webinar. So first of all, we'll explore what is the need for histograms to be created. Prior to 12c, two types of histograms are available: frequency histograms and height balance histograms. So we'll look at them. But there were some issues with histograms in 11G. So we will see what were those issues and how does 12C plan to resolve those issues by introducing two new types of histograms, that is top frequency histograms and hybrid histogram. So at the end of the session, we'll have a question and answer session. If you have any queries, then you can post them, right? So let us start. First of all, now what is the need for histograms? Now, whenever a SQL statement is issued, so optimizer has to come up with an execution plan. So what does it do? So whatever information is available to it, so based on it, it decides what is going to be the access method, join order, and join method, and finally it arrives at an execution plan. Now, what that information, how is it going to be made available to the optimizer? That is by means of optimizer statistics. So if basic statistics of a table have been gathered and the data distribution is uniform, in that case, optimizer is bound to come up with an optimal execution plan. But what happens if the data distribution is skewed? Now, what do we mean by skewed data distribution? Now, here is an example. Now, we have a table in which there is a column called ID, which is indexed, and there are 26 distinct values in the column. So here you can see in this bar chart, now this x-axis represents the 26 distinct values and y-axis represents the number of rows for those corresponding values. So from this graph itself, from this bar chart itself, you can see that there are more than, in this table we have 120 rows and more than 40% of the rows, that is 50 rows, have a value of ID equal to 8. So this is an example of skewed data distribution. Your data is not uniformly distributed across different values in the column. So in this case, if optimizer assumes a uniform distribution, it will result in a bad execution plan. So in this case, in such cases of skewed data distribution, we need to provide histogram. We need to provide additional information to the optimizer. We need to tell, okay, there are 50 rows with ID equal to 8, and maybe there are only 5 rows with ID equal to 1, and so on, so that optimizer can decide on a good, efficient execution plan. So let us see now, prior to 12C, that is till 11G, two types of histograms could be created: frequency histograms and height balance histograms. So what is the difference between them and what are the features of these histograms? Now, as far as frequency histogram is concerned, it records each different value and its exact cardinality. Cardinality means how many number of rows are there for that particular value. So it creates different buckets. So each bucket stores the cardinality of one particular value. So one bucket contains exactly one value. And in which scenario is the frequency histogram created? When number of distinct values are up to 254. Now, why this 254? Because till 11G, there was a limit on the number of buckets that can be created, and that limit is 254. So frequency histogram will be created only when there are up to a maximum of 254 distinct values in the column. Now here NDV is a keyword that we'll be using very frequently. So NDV basically stands for number of distinct values in the column. And there is another symbol NB. NB stands for numbers of buckets. So if one thing, if number of distinct values are up to a maximum of 254, and additionally the number of buckets that you have specified, they are at least equal to the number of distinct values. So it means so that I have at least one bucket available for every value. So in such a scenario, frequency histogram will be created. So one value, it resides entirely in one bucket, and size of the bucket will give you the cardinality of the value. So since we have one bucket dedicated for every value, so this histogram is very precise. Optimizer knows what is the cardinality of each distinct value in the column. So here you see we are trying to create a histogram on column ID of this table that we saw earlier. So we saw that there are 26 distinct values here, although we have not specified the number of buckets. So by default, it automatically takes the number of buckets as the number of distinct value. So here you can see there are 26 distinct values. It has automatically taken 26 buckets, and a frequency histogram has been created. Now, how do we find out what is stored in this histogram, in this frequency histogram? Well, the histograms, they are visible from view DBA histogram. So here if you see, we have two columns. One is endpoint value and other is the endpoint number. Now what do these columns represent? Well, endpoint value basically represents the value that is being stored in the bucket. That is the ID column that we're talking about. And endpoint number represents the cumulative frequency. So here you can see in this bar chart, these red bars, they represent the cumulative frequency, and these blue bars, they have been arrived at by subtracting the cumulative frequency of successive values. Now, for example, for this endpoint value of 2, the cumulative frequency is 6. So how do we arrive at how many number of rows are there with this value? We simply subtract these two successive values. So 6 minus 4 comes out to 2. So it means there are 2 rows with endpoint with that column ID value equal to 2. So it means this frequency, using this frequency histogram, optimizer can accurately determine how many number of rows are there for that particular value. Let us see this frequency histogram in action. Now we are trying to, now we'll see the execution plan that is generated by the optimizer when we are searching for ID equals to 8. So we already know that there are 50 rows, and optimizer also comes up with this value. How? Now here if we look at this histogram, now for this value of 8, the cumulative frequency is 65 and the prior cumulative frequency is 15. So it simply subtracts and comes up with the cardinality of 50, and which is the precise, which is the accurate value. And although this column is indexed, but still it chooses a full table scan because it knows that a majority of the values in the table have this value. So that is how frequency histogram is very precise, and it helps the optimizer comes up with a good execution plan. Now let us look at the other type of histogram that was available prior to 12c, which is height balance histogram. Now we said that there is a limit on the number of buckets that could be created till 11G, and it was 254. So one scenario when height balance histogram will be created will be when number of distinct values are more than 254. It means those values, they cannot fit in the maximum number of buckets that can be created. And the other scenario is that number of buckets that we have specified to be created, they are less than number of distinct values in the column. Again, all those values, they cannot fit in the number of buckets. It means we do not have one bucket dedicated to each value. So one bucket will contain multiple values. So how are those values arranged in this case? Now height balance histogram, it will distribute all the rows evenly across the buckets which are available, so that all the buckets have almost the same number of rows, right? So since we have multiple values in one bucket and we do not have a dedicated bucket for every value. So this histogram is less precise as compared to frequency histogram. So here you see we are creating a height balance histogram. So here we have, although we have 26 distinct values in the column, still we have specified that we want only 20 buckets to be created. Now since number of buckets, they are less than number of distinct values, a height balance histogram has been created. So let us see how the data is arranged in case of height balance histogram. Again, the view is DBA histograms, but now the interpretation of these columns, endpoint value and endpoint number, it differs from what was there in case of frequency histogram. Now, endpoint number, it represents a unique identifier of the bucket. Now, in case of frequency histogram, this was representing the value that was stored in the bucket. But in the case of height balance, since one bucket can contain multiple values, so it cannot store the value. So it has been just used to assign a distinct number to every bucket. You can say it is the ID of the bucket, right? And what does this endpoint value represent? Endpoint value represents the largest value that is stored in the bucket. Now here if you see, this is how, now we have all these buckets. So what it does is, it computes the size of the buckets. And how does it compute? We know the total number of rows in the table are 120. And number of buckets we have specified at 20. So it means size of every bucket is 6. So it simply creates 6 buckets, 20 buckets, each of size 6. And it simply keeps on placing those values in the ascending order in these buckets. So here you can see we have multiple values in every bucket, and this endpoint value, it represents the highest value that is stored. So you see 2, here it is 2, here highest value is 6, and here you can see 6, and so on. And now one bucket is containing multiple values, and also now since value 8, we have 50 rows with value 8, and those 50 rows, they cannot fit in one bucket. It means this value 8 is spanning multiple buckets. So what we can say, in case of height balance histogram, one bucket can have multiple values and one value can span multiple buckets. And on top of it, now if you see here, buckets starting from 3 to bucket number 10, all of them, they have the value of 8 stored here, right? Although this data is arranged in 20 buckets, but here if you look at this output of DBA histogram, it is showing only 14 rows selected. Why? Because it is for this endpoint value of 8. Now if you see, it is storing just the highest bucket number. So if you know, these are the bucket IDs. So 0, 1, 2, and after 2, you directly see this value 10. Why? It is basically performing a compression. It is not storing each and every row which has the same highest value. So it simply compresses. Now here you can see, if this value is 2 is followed by a number which is not the next number in the series, this basically means that all the buckets from 3 to 10, they have the same end value, which is 8, right? So this is how the values, they have been arranged in a height balance histogram. So how does optimizer decide the cardinality of the various values? Well, in this case, optimizer simply distinguishes between various values as popular and non-popular. So what is a popular value? A popular value is one which occurs as an endpoint value of multiple buckets. For example, in our case, the value 8 is a popular value. And what is a non-popular value? So any value which is not popular is non-popular, which is not popular is considered as non-popular. It means any value which is an endpoint of only one bucket or is not an endpoint at all. For example, this value 1, it is not an endpoint at all. Value 2 is an endpoint of one bucket only. So all such values, they are considered as non-popular values. Now let us see this height balance histogram in action and see how does it estimate the cardinality. So first we consider the case of popular value. So in our case, the popular value is 8. So how does it estimate the cardinality? So cardinality of the popular value is arrived at by multiplying the size of the bucket, which is 6 in our case, multiplied by the number of buckets with the value as endpoint. Now here we already know that id equal to 8 is an endpoint of 8 buckets. So it multiplies this number 8 with the number of 6, which is the bucket size, and it arrives at the cardinality of 48, as you see here. Whereas actually there are 50 rows with id equal to 8. It means optimizer has made a mistake, right? Now this was the case of popular value. Now let us consider non-popular values. Again, non-popular, we have two cases: for value which is an endpoint of only one bucket, and a value which is not an endpoint at all. We'll consider both the cases. So first we look at a case when the value is an endpoint of only one bucket. So here we have id equal to 15. It is an endpoint of only one bucket. So actually there are 5 rows with this id equal to 15. We can see here id equal to 15. So here you can see it is an endpoint of only one bucket, and there are 5 rows with id equal to 15. But what does optimizer estimate? Optimizer estimates that there are only 3 rows. Why? Because it basically arrives at the cardinality of a non-popular value by multiplying density with the number of rows in the table. So here again the optimizer has made a mistake. Now let us consider a case of a non-popular value which is not an endpoint at all. So here the value id equal to 3. Now if we go back to our histogram, so here you can see id equal to 3. It is not an endpoint at all. So what does optimizer estimate in this case? Again, it estimates the cardinality as 3 only. It means it is estimating the same cardinality for all the non-popular values, whether they are endpoint or not. So here again, optimizer has made a mistake. So what we can say, prior to 12c frequency histograms, they were accurate, but they could be created only when number of distinct values, they were less than or equal to 254. In case of height balance histogram, optimizer, it was a fair chance that optimizer may misestimate the cardinality for both popular and non-popular values, as we just saw. And in case there is a value which is endpoint of one bucket and almost fills up another bucket, might be considered unpopular because it is an endpoint of only one bucket. So again, optimizer might make a mistake. So how does 12c improve things with these histograms? One thing, now the upper limit for the number of buckets that can be created, it has been increased to 2048. It means if I have up to 2048 distinct values in a column, I can create a frequency histogram and let optimizer know what is the exact cardinality for each distinct value. On top of it, now 2 new types of histograms have been introduced to resolve those cardinality misestimates due to height balance histogram. It means when number of distinct values, they are more than the number of buckets. In that case, now 2 new types of histograms can be created, which can improve the cardinality estimates made by the optimizer. So those 2 new histograms are top n frequency histograms and hybrid histograms. So let us look at them. So first of all, we talk about top frequency histogram. This histogram is useful when a small number of distinct values dominate the data set. It means there are only a small number of values which are occupying most of the rows, and there are very few distinct values which are for which we have only 1 or 2 or 3 rows, right? So how does it going to act in such a case? In this case, it will capture only the highly popular values. It will simply ignore statistically insignificant unpopular values, because a value which is more popular, maybe it is the one which is going to be queried, most of the time. So it will simply capture those values accurately and ignore the values which occur very sparsely. So in which case such kinds of histogram will be created? Well, number of distinct values, they are more than the number of buckets, that we already know. And how does it decide? What is the criteria for deciding that a small number of values are dominating the data set? Well, in this case, the percentage of rows occupied by the top NB frequent values. It means as many number of buckets are available. So the percentage of rows occupied by top these many frequent values, it should be equal to or greater than the threshold P, where P is defined by this expression. So in such a case, if we assume that small number of values are dominating the data set and top frequency histogram will be created, and there is an additional requirement that the estimate percent, now when you gather the statistics, this estimate percent, it has to be set to auto sample size, which is the default value, and only then this histogram will be created. Otherwise, height balance histogram will be created, right? So what are the various features of this top frequency histogram? It stores one value per bucket, just like a frequency histogram. One value is contained entirely in one bucket, again just like a frequency histogram. Cardinality of the value is equal to the size of the bucket. But now, and again just like a frequency histogram, the bucket size is variable because different values can have different cardinality. So bucket size can be variable, and it is precise for all the endpoints captured. And it captures top NB most popular values. It means it will capture only those top values which are most popular, which are equal to the number of buckets. So that is what is different from normal frequency histogram that used to be created in 11G. Now let us see this top frequency histogram in action. So here we are going to create a histogram. Now this is 12C, right? Where although we have 26 distinct values, but still we specify the number of buckets as 20. Here you can see, right? And what is the threshold for 20 buckets? So we apply this expression and it comes out to be 95. So what does it mean? That top 20, which is equal to the number of buckets, most popular values, they should occupy 95% of the rows. Now since this criteria is satisfied in our case, and estimate percent, which is auto sample size, which is the default value, so a top frequency histogram has been created. So number of distinct values are 20, number of buckets are, number of distinct values are 26, number of buckets are 20, and a top frequency histogram has been created. So this histogram precisely captures the cardinality of top 20 most popular values. The 6 values which are remaining, so 26 minus 20, so whatever 6 least popular values are left, they are not captured at all. So let us see, look at this top frequency histogram. So here you can see 20 rows selected. So only top 20 values, they have been captured, and endpoint value, it represents the key value, just like a frequency histogram. Endpoint number represents a cumulative frequency, again just like frequency histogram. So the only difference is it is capturing only the top 20 most popular values, and those values, they are exactly captured. So optimizer knows what is the exact cardinality of these 20 values. So let us see this top frequency histogram in action. So first we will consider the case of a value which was an endpoint of only one bucket and was considered non-popular in height balance histogram. So we use the same value, ID equal to 15. It occurs 5 times. In case of height balance histogram, it had misestimated 3 rows for this value. Or in case of top frequency histogram, it is an endpoint. Here you can see ID equal to 15. It is an endpoint. So it actually estimates the cardinality of 5 rows. It means for non-popular values, which is an endpoint top frequency histogram, it performs better than a height balance histogram. Now let us consider a non-popular value which was not an endpoint in height balance histogram. So we use the same value, ID equal to 3. It occurs once. In case of height balance histogram, optimizers had misestimated 3 rows for this value. But in case of top frequency histogram, again it is not an endpoint because it is one of the 6 least occurring values. But here again you see optimizer is estimating 1 row to be returned, which is the exact value. So it means a top frequency histogram, it is better than height balance histogram. So it captures the occurrences of popular values at the expense of not capturing the data for least occurring values. It accurately estimates the cardinality of top NB popular values, where NB is the number of buckets. It is useful for cases when data set is dominated by a small number of values. Now let us look at the other new type of histogram that is introduced in 12c, that is hybrid histogram. Now why it is called hybrid histogram? Because it combines the characteristics of both height balanced and frequency histogram. So what are the prerequisites? When will this histogram will be created? Again, the number of buckets, they have to be less than number of distinct values. And the criteria for top frequency histogram does not apply. It means a small number of values are not dominating the data set. So please, the percentage of rows occupied by top NB most popular values is less than the threshold P, which is defined like this. And the sampling percentage, again, it has to be auto sample size. So you see both the two new types of histograms that have been introduced, they will be created only if this a sampling percentage has been set to auto sample size, which is the default value. If you change this value, in that case, height balanced histogram will be created, right? So what are the new features? What are the new things with this hybrid histogram? First thing, now in addition to the columns, endpoint number and endpoint value that we discussed earlier, it stores a new column, which is called endpoint repeat count. And what does this store? It stores the number of times the endpoint value is repeated. It means now we can accurately estimate the cardinality of endpoints because we are storing this, right? And another thing that is very good about this hybrid histogram is it captures more endpoints. And how does it do it? It stores all the occurrences of every value in the same bucket. Now you see, in case of height balance histogram, we saw that the value 8, it was spread over I think 8 buckets. It was spread on over 8 buckets. But now in case of hybrid histogram, it will store it only once. It means now we will have 7 more buckets available to store 7 more endpoints, and we can accurately estimate the frequency of the endpoint by means of this new column that is introduced, endpoint repeat count. So it means now it makes available more buckets to store more endpoints. So we are not wasting our buckets to store a value which is repeated over multiple buckets. So in case of, so it means now just like a frequency histogram, it stores all the occurrences of values in the same bucket, right? Let us see. Now let us create this hybrid histogram. Again, we specify number of buckets as 20, where our distinct values are 26. And as we calculated the threshold P was 95. Now we have to modify our data set a little so that a hybrid histogram will be created, so that my data set, a small number of values are not dominating it, right? So how do we achieve it? We delete 20 rows with the value of ID equal to 8 from the table so that it qualifies for hybrid histogram. So once we have done it, and then we create a histogram. Now in this case, a hybrid histogram has been created. So number of distinct values are 20, number of 26, number of buckets are 20, and the values, so a small number of values do not dominate the data set. So hybrid histogram gets created. Now let us see how is the data spread across different buckets in this case. So here we saw we have 3 columns. So endpoint value, it stores the largest value in the bucket, just like hybrid histogram. Endpoint number, it stores cumulative frequency, just like a frequency histogram. And endpoint repeat count, this is the new column that has been introduced, which stores the frequency of the endpoint. So here now you see, now just look at this. Now here you can see now this value 8, which was earlier occupying 8 buckets, now it has been placed into only 1 bucket. It means now we have so many extra buckets available, 7 buckets. So 7 more endpoints can be stored now. And another thing, now this is now here you can see there are some buckets in which multiple values are stored. So in this bucket, values 6 and 7 both are getting stored. So what we can say in case of hybrid histogram, so these histograms, they have features of both frequency histogram as well as height balance histogram. So what are the features similar to frequency histogram? One thing, all the occurrences of a value are placed in one bucket, that ID equal to 8. Endpoint number stores cumulative frequency, and the bucket size is variable. Now remember, in height balance the bucket size was same, but in case of frequency histogram we have a variable bucket size which holds true for this hybrid histogram as well. And what are the features similar to height balance histogram? Number of values captured, they are less than the number of distinct values. One bucket can contain multiple values, and endpoint value represents the largest value in a bucket. And it captures more endpoints than height balance histogram we saw, because now we are compressing, we are storing all the multiple values into one bucket. And it is an improvement over height balance histogram when data set is not dominated by a small number of values, right? So in conclusion, we can say that in 12c, frequency histograms can be created up to 2048 distinct values in the column as compared to 254 in 11G. Top frequency and hybrid histograms are designed to overcome the flaws of height balance histograms. Both new histograms, top frequency as well as hybrid histogram, they will get created only if estimate percent is set to auto sample size, which is the default value. Top frequency histogram, it accurately estimates the frequencies for only top occurring values if a small number of values dominate the data set. Hybrid histogram has features of both frequency as well as height balance histograms, and a hybrid histogram captures more endpoints as compared to height balance histograms and estimates their frequency accurately. So these are some of the references, some of the links which I refer to while preparing this presentation. And now if you have any questions, then I would try to answer them to the best of my knowledge. Hello Aman, are you there? Hello.
Hello?
Yeah, Aman.
Yeah, Anju this side.
Okay.
I think there might be some problem in the connection. That's why we're not able to hear the Aman voice.
So I hope the webinar could be listened to by the audience.
Uh, Guys, first of all, I would like to thank everyone who has joined this session. And it was a really informative session. Thank you, Anju, for that. And what we will be doing, we'll be sharing these slides with you. And in case you have any questions that you want to ask to Anju, you can put it on our website. You can put it on our Facebook page. So we will be sharing these slides. We'll be providing you the link on our Facebook page, so you can download these slides. And if required as well, we're gonna tag Anju there and we directly ask questions to her. Anju, would you like to add anything?
Let me get conclude this session. Is that correct?
Okay, so I think probably we are. Yes, Anju.
There's a question in the chat. Jamal Khan is asking, can we choose our own histogram method for any particular table? Well, see, till 11G, we could decide whether a frequency or a hybrid histogram be created by specifying the number of buckets, right? If number of buckets they were less than the number of distinct values, a height balance histogram would be created. But if they were more or equal to, in that case frequency histogram would be created. But in case of 12c, based on the data distribution, it will decide whether the table is a candidate for a top frequency histogram or a hybrid histogram. Well, Deepak, yes, you can continue.
Quick question, Anju. Have you seen any kind of performance degradations with this 12c new histograms being available? Like any kind of performance degradations which have happened due to this new form of histograms? Have you encountered anything in your testings or in your research?
Well, I have not done much of testing, so I can't really comment. But on the face of it, it looks like that these new type of histogram, they should be performing better than 11G. Like I have not done extensive testing on them.
Okay. Okay. Right. All right. Any more questions, Deepak? Any questions?
No, man, I've already requested the audience for the same. You can take over.
Okay. So probably then we can close the webinar right now. Anju, I think we'll be closing the webinar now. Thanks a lot for your time, and it was a very productive and an excellent webinar again by you. This is the second webinar, I guess I must mention, everyone, from Anju. She has already done one webinar for us that was about 12C optimizations in the execution plan. In case you haven't watched it, you should watch it on our channel. You can just search on YouTube for AIOUG North India chapter, and you should be able to see the another webinar, which is actually the recorded version of the one which we have done. And since we are over here, I must mention that this is the month of November, and we are doing a national level conference called Sangam. Anju is going to be a speaker over there as well, so it's going to be happening in the month of November. Sangam, you can actually check all the details and the speakers information from the Sangam 15 website. So you can just search on Google about Sangam 15, and you should be able to find out that there's a long list of people coming up, and I think this is going to be one of the best places to be into. So you can actually go to sangam15.sketch.org, and you can actually see the entire schedule from there. I'll just repeat it one more time, sangam15.sched.org, and you can actually check the entire schedule from there. So once you're going to be over there, you can actually have 2 days of entire conference filled with a lot of Oracle content. I think that's probably going to be one of the best places to be. So it's going to be 21st and 22nd, of the November month. All right. So with that note, I think we'll be closing the webinar. Once again, Anju, thanks a lot, and thanks to everyone who has connected. I hope the webinar is going to be productive for you and useful for you. Please leave us your comments, and do subscribe to the channel in case you want to get the updates about the new videos or any such kind of thing being posted on the channel. Thanks a lot, Anju, and for everyone, have a happy weekend and have a very happy Diwali as well.
Okay, thanks Aman, and thanks all the people who attended this session. And I hope we'll meet during Sangam again. Right?
Absolutely, absolutely. Thank you, thank you, thank you.
Okay, bye.
Thanks, bye-bye. Thanks, everyone.